Okay, so this is a discussion week number 4, discussion problem number 1, and what is called the percent ionic characters. And let's read the problem. The measured dipole moment, okay, something the bonding, and this is a carbon monoxide, and oxygen is more electronegative, and this is a carbon monoxide. We has essentially, if you look at the Lewis structure, it actually looks like this. And it has, this one is more electronegative. Okay, and so it has a dipole moment, looks like this way. Electrons are being pulled this way. And the measured dipole moment, which is a mu measured, it has been known as a 0.112 D. D is a unit of Debye, with a scientist who work on various areas, including this, the polar bonding nature of this. The CO triple bond has a separation of 112.8 picometer, so that's a 10 to the minus 12 meter, and in the length. So calculate the percent ionic characters. So the question is the percent ionic character. That is essentially you have measured it, that's the real, over you have something that is estimated based on the calculation. And then you want to multiply by 100 for making a percent. And so we know it, the measure value is here. And so we just need to calculate. So let's just shorten it as a calc. So that's a calculated value. And that is Q times R. So it is a multiplication of charge by a distance of separation distance. Okay, so what will be a charge for one electron to be separated? And this is a 1 electron charge. So that will be a, if you look up the reference table, that will be 1.6 times 10 to the minus 19 coulomb. Okay, so we are just assuming that one electrons are completely give away to the other one by distance r and by electronegativity differences from one atom to the other. So in this case is carbon and an oxygen. That will be essentially 100% ionic, right? And so that will be our indication. And what is measured is, as a consequence, is not fully whole charges being transferred for that distance. So therefore, we are giving this as a reference point. Is, let's say that's a 1 electron charge, and what's the distance? And that will be 112.8 times 10 to the minus 12 meter. Okay. So by doing so, you will naturally have some unit. Okay, and then okay. So by doing so, you will have 1.6, 112.8, 10 to the minus 19 plus 12 coulombs. I just didn't calculate this one, but I just wanted to emphasize the unit conversion. So this one has a unit of coulomb times meter, and then what you need to do is you have to do the unit conversion. So which is I want coulomb meter converted into a unit of polarity, which is a Debye, and that's the unit. And the 1 Debye has been known as 3.34 10 to the minus 30. Okay, so you want to do that. And then when you calculate those numbers, now coulomb meters and the device comes in, and that will give you a 5.40 Debye. Okay, so therefore, using this value, the calculated value is 5.40 Debye. Okay, if whole electron, one electron is given to the oxygen, that will be a 5.40 Debye, knowing the geometry, separation of the distance. Okay, this is a distance. Whereas the measured one is 0.112 Debye. So that will be a essential nature of the polarity ionic characters. And then this one will be essentially 2.07%. Okay. So here I explained it to you about the Debye characters. The separation is, your reference point is the percent of ionic character is measured over the calculation. The calculation is essentially assuming the one electron charge separation for the same distance of r that has been geometrically given. And then you also can look up the reference table how to convert the coulomb meter to the Debye so that you can have this unit in the Debye unit. Thank you for your attention.